Hey, real-time communication is everywhere, from video call to online games. But how secure is your signaling? In this course, I'm going to show you how to protect your WebRTC signaling using end-to-end encryption. It means even the data that are going to set up a private connection are going to be safe. But before we dive in, make sure you'll subscribe to my YouTube channel. Hey and welcome back. Before we start, I have to mention that this is an advanced course that you have to know some knowledge about cryptography and video call with WebRTC, of course. I have two tutorials that you have to watch before this course gets started. So you should get on board with video calling using WebRTC and of course, cryptography in Android. I will for sure add the links of the tutorials here, and here are two tutorials that you have to watch. The first one is MiniChatClone, here's the GitHub repository, and the next one is Android Cryptography, which I'll add some libraries to it that will explain everything about cryptography and stuff like this. So let's dive to the sliders and do a review that what we are going to do. So what you will build is a secure peer-to-peer signaling system and of course an AES encrypted session payloads, RSA encrypted key exchange and Firebase matchmaking. So far we have done the matchmaking and peer-to-peer signaling. In this course we will just add secure signaling to this library. And of course we are going to use Kotlin and Jetpack compose, WebRTC native Android, Firebase for signaling, RSA and AES encryption or asymmetric and symmetric encryption, of course. So far, what we have been doing in the previous version of this course, this MiniChat client, we had two users finding each other with looking for match status and then exchanging the data using the data field easily. But what we are doing in this course, we are going to generate an RSA key pair and we will publish the public key of each user into the Firebase. So it will look something like this. Each user will start adding his own public key to the Firebase panel. So other users that are going to exchange data with this guy, user A, will have access to the public key of the user so he can encrypt the file using target's public key, and the user A will understand that the data is encrypted using my own public key and I'm able to decrypt using my own private key. So after uploading public key to the Firebase, we are going to generate an AES key for each signal. Usually you will generate one AES key for each session. But since I'm not exchanging that much data for the signaling, I'm creating an AES key for each signal. But right now what we are doing, we are encrypting the data using AES key or symmetric encryption and then encrypt the ES key using RSA and exchange it to the target. So you can see that the data using this is going to be something like this. We have the encrypted data using AES key and also we are encrypting our AES key using RSA publics of the targets. You can see the key is too much big. And what happens right now? User B will receive this data and he knows that he has to decrypt this AES key using its own private key. And he will decrypt this key using his own private key. And now he has access to the same AES key that the user A has been generated. So he will decrypt the AES key and now it's ready to decrypt the data. Simple as that. Now why it matters? Because we have to make sure that no one else can listen in on your calls, even if they try to spy on your internet traffic. The information used to connect two users like offer, an answer, an ICE candidate is hidden from the hackers or unwanted parties. Using encryption helps you follow privacy laws like GDPR, and it's important if your apps handles user data, of course. And then you'll understand how secure apps like WhatsApp and Signal protect user communication behind the scene. People trust apps that care about their privacy, of course, and adding encryption shows you take security seriously. This course shows how to combine fast encryption AES with secure key exchange or RSA, a common method in secure apps. So let's dive to the code and see how we can handle this securing WebRTC signaling using cryptography. Also make sure you'll subscribe to my YouTube channel. Till the next video, see you everyone.